Hey folks, in this lecture we are going to talk about interfaces, which is the final type of class that you can implement. So to review, we have written concrete classes, which is what you had done until we started this whole section. So class, a curly braces, you give a bunch of attributes, you give a bunch of methods, life is good. Then we talked in the last lecture about an abstract class, and in that case you wrote a class, but you didn't give the definition for at least one of the methods when you were writing the abstract class. At that point, another class has to inherit from that and must override that method and write all of the details of how that method is going to work. So an abstract class is a way for you to show somebody that you want them to write specific methods. So what is an interface then? Well, an interface is kind of like an abstract class. As a matter of fact, it's very like an abstract class, but there's a few more restrictive rules with regard to it. So to understand, we need to go back to this example that we talked about a couple of weeks ago or a week ago. We mentioned that C++ has the concept of being able to inherit from two different parents. And so you could have a man and you could have a wolf and you might need to have a werewolf. And we said at the time, neither C Sharp nor Java has the ability to do this. But there are times you might want to be able to do this. So let's take a phone. If you're familiar with having some form of phone in your pocket, you are aware of the fact that the phone does a number of different things. It is capable of receiving phone calls. It's capable of receiving instant messages from whatever your messaging app is, Discord, WhatsApp, Hangouts, iMessenger, whatever. And it's also capable of surfing the web, and it's capable of doing all these other things. It's a camera, it's all of these things. So if you were to try and model a cell phone, into a class, you'd quickly realize that you would need it to inherit from the phone class, because that explains how phone calls work. You'd need it to inherit from the internet class, because that's how getting to the internet works, and probably the messenger and the instant messenger and the camera and blah, blah, blah. There would be a whole bunch of parents that you would need to pull from in order to write that. So how does that work? Well, to remind you of why this is a problem and why they chose not to allow you to inherit from two children, to remind you as to why this is a problem of inheriting from more than one parent, we have this example where we have a man and a wolf, and they are both inheriting from mammal. This is allowed. We can have more than one class that's allowed to inherit from a mammal or from a parent. And in this case, it's clearly the case that there is a run method, which is public, and both man and wolf have overridden that. We know that because it's listed here in the UML, and it wouldn't be listed unless it has been overridden. So when we were to create this magical child that we can't do, but if we were to somehow be able to say inherit from both of these two parents, you would have the question of which run does it do if you call run on werewolf. And that's what's called the diamond of death, because it's not clear which direction you're supposed to go, and all of this is very, very confusing to the compiler. Therefore, Java and C# did not implement it. So the simplest answer to this question is just don't allow this, period. That's what Java and C# did. C++ did something different, and you're going to have to wait until your data structures class to see what's going on over there. So how do you get around this? Well, both Java and C# have something that's called an interface. An interface is effectively an abstract class with a few more rules that you can implement more than one interface. So a child can do the diamondy thing where you're getting from two different parents, but the two parents have to be interfaces. And then the rules that are placed on an interface are basically there to stop you from getting too crazy. So the first thing to say is that an interface is very, very similar to an abstract class, which is great and bad all at once, because it is going to confuse you forevermore. I need you to remember that there are concrete classes. There are child classes that inherit from concrete classes. There are abstract classes. Child classes can inherit from abstract classes, and then they just must override any abstract methods. And now there are interfaces, and children can implement multiple interfaces. They don't extend they implement. There's a different verb for it when it's a interface. So at the top level, we had concrete classes, we had abstract classes, and now we have interfaces. And children can do any combination of the above within rules. So this allows for the circumstance where you might want to inherit, sort of, two different parents. So what are the rules? Well, the first rule is that all methods inside an interface must be abstract, period. This is very different than an abstract class. If you've just watched the abstract video, you remember in there, I wrote a method and I wrote a class that was abstract. Some of the methods had code, some of the methods did not. That is allowed in an abstract class. It is not allowed in an interface. All methods in an interface are considered abstract. You cannot have any code. Even if you put open curly brace, close curly brace, it is incorrect. There can be literally no code. All you put in are the method headers. You don't have to list the word abstract or virtual. It's implicit because every method inside an interface is inherently abstract. You cannot put constructors inside an interface because you cannot instantiate interfaces. They are not objects. They are not classes that you can instantiate into objects. There's a convention that when you make an interface, you generally call it I followed by whatever it is. You generally put the word or the letter I at the beginning of the name. So if your interface deals with talking, then maybe it would be iTalkable. If it's about phones, it would be iPhone, yes. All right, you can implement multiple interfaces, and you do that with a comma. We're going to see that, and you absolutely cannot instantiate interfaces. All right, so a class that implements an interface has a choice. And this is kind of a little deep. The class can either override the methods, all of them that are in the interface, which means it's implementing all of those methods, or the class can declare itself to be abstract. So you can have an interface that then has an abstract class as its child, which then has a concrete class as its child. As a matter of fact, you could have multiple abstract classes in the middle, some that implement some of the methods and some that implement other methods, and you just have to keep passing down the abstract ones until you get far enough down that one actually implements it. All right? So that's a little bit meta. Let me go over that again. In general, you're going to have an interface, and then you're going to have a concrete class that implements that interface, and life is going to be good. That's the most common scenario. Sometimes you're going to have two interfaces and a concrete class that implements both of those interfaces. And that's a common scenario, and that's good as well. But the weird scenario is you could have an interface or more than one interface, and the child could itself be abstract. And what that means is the abstract class can implement some of the methods from the interface, and the rest of the methods it would still label as abstract. In all the same ways that you can't instantiate an interface, you cannot instantiate an abstract class, even if it is implementing an interface. So there has to be a third layer here before you can actually make an object of it, and that third layer has to be a concrete class that finally implements all the remaining methods of its parent. All right? So an interface has all abstract methods. Typically, a concrete class will implement that interface and will give code for all of those abstract methods. But it is possible that you could have an abstract class in between an interface and a concrete class. All right, so let's take a couple of examples in actual code here. So we have an interface called Talkable, which is going to have a method called talk, and it's going to be a void method. Please note, I didn't have to say public, I didn't have to say abstract. All of that is implicit. If you are writing an interface, it will be public and it will be abstract. So you can put them in, it doesn't hurt, but they're absolutely unnecessary. So in this case, what we're going to do is we're going to create a concrete class called dog, and we are going to implement Talkable. All right, this is Java code. In Java code, you say class dog implements Talkable. Please note that when it was an abstract class or a concrete class that you were inheriting from, you would have said class dog extends mammal. There's a different word when it's an interface. You implements the interface. You extends the abstract class. All right? That's in Java. In C#, the equivalent is a colon. Because in C#, the colon means the same thing whether it's an interface or whether it's an abstract class. It doesn't differentiate. So in C#, you can say class dog colon iTalkable, and it understands you mean you're implementing an interface, as opposed to in Java where you have to call out what you're doing. All right? So in each case, at this point, we are overriding talk. We have to do that because we are implementing an interface, and the interface only had abstract classes, or abstract methods, sorry. So in that case, we have to implement all of the abstract methods. Therefore, we're overriding public void talk, and we're saying that it now does woof. At this point, because we have created a concrete class, we know that it's concrete because everything that it is implementing in Talkable has been overridden. Talkable only had one method, and we overrode that one method. Therefore, this is a concrete class. So now we can instantiate it into an object. Dog_d equals new dog, and we can certainly call d.talk, and it will do that. So the interface is nothing more than a list of all of the methods that you intend to write. There are no constructors, just a bunch of methods that you intend to write. There can be attributes up there as well. All right. A concrete class, when it's implementing an interface, it must implement all of the abstract methods of the interface, which are all of the methods of the interface. And then at that point, you can instantiate it like normal. This is the same code in C#. Again, nothing magical. It is the word interface. The only thing that's different really is this colon, and you should have the word override in here, but it actually is not necessary. And actually, I may be wrong about that. Okay, this is inherently overwriting, but because it realizes it's an interface, I think in C# it neither requires nor will allow you to put the word override in there because it's implicit. All right. So, can you have an abstract class in the middle? Yes, you can. So this is a weird example, but you could extrapolate in your head how you might get here. So we have an interface Talkable the same as before, and it has a method called talk, which is going to be public and it's abstract. Now I'm creating an abstract class dog, which implements Talkable. Because I marked the class as abstract, I don't have to actually implement all of the things that are in the interface. And since there's only one thing here, I'm not going to do anything. So this is actually a valid set of code. It's not a useful set of code, but this will compile. What you are not allowed to do is instantiate dog because it's an abstract class. So again, this is weird. What you would now need to have is another layer where you would say class Chihuahua extends dog, and now you would actually have to implement talk in Chihuahua. Again, an abstract class can have a mix of abstract and concrete methods. So if there was 5 methods up here, it could have implemented 3 of them, and then the later concrete class could implement the other 2. This is the possibility of having more than one interface, which is the whole point of what we were doing here. So we have interface iTalkable, which knows how to talk, and we have interface iConsumer, which knows how to eat. So I can now say class dog implements, this is C# code, iTalkable and iConsumer. Note that there's a comma in here. We simply list all of the different interfaces that we want to have. And in this case, we're doing an public void talk and public void eat, which just print out some nonsense. All right, so you may be wondering in your head, okay, so hold on, in C#, you use a colon when you're extending a parent, i.e. you are inheriting from a parent and you want to overwrite stuff or whatever. And you also use a colon when you're doing an interface. So could you have an interface and also a concrete or an abstract class? And the answer is yes. The rule is you can have an unlimited number of interfaces that you are implementing and exactly one class, which can either be abstract or concrete, that you are inheriting from. So one class, unlimited numbers of interfaces. That's the rule for both C# and for Java. It's going to look very similar, except you put the word implements, and then you list the interfaces. Again, you probably should have called them iTalkable and iConsumer in both cases, but it's just a convention. So in Java, you might say class dog extends mammal space implements talkable comma consumer. All right, this is apparently a dog that eats and talks on the phone. All right, so how do we actually use this in a real example? So imagine you're building a video game that uses some form of artificial intelligence, and it's a magical world where non-animate objects can suddenly come to life. So where would you have interfaces here? Well, I'm going to leave this for you to think about for a little bit, and you're certainly welcome to ask questions in emails if you want to. There are many correct answers here. It's not like there is only a single answer. But the individual objects that are in the video game, some of them would need to be able to do certain things, and some of them would need to be able to do other things. So like a tree probably doesn't need to be able to walk, but a bad guy or a good guy does. An arrow needs to be able to fly through the air, whereas a ball needs to be able to roll on the ground or fly through the air. So you might be able to see from what I just said that there are places where interfaces would make sense. And the interface would be a generic way of you specifying that all things that are able to, let's say, fly through the air would need to implement the following features, which is how far can they fly, as well as, do they turn while they're flying, or do they just go in a straight line, and so on and so forth, because a ball works very differently than an arrow when it's thrown. So there's a hint. So in summary, we have concrete classes which can be inherited to children. We have abstract classes which can be inherited to children, and those abstract classes, if they're going to have a concrete child, they must implement all of the methods that they inherited that were abstract. They may have other methods, that's fine. If we have an interface, then you are going to implement the interface if you're in Java, or you're just going to use a colon if you're in C#. But at that point, all of the methods in the interface must be abstract. So to review, in a concrete class, no methods are abstract. In an abstract class, at least one method is abstract, but there can be a mix of abstract and concrete methods. In an interface, all methods are abstract. There can be no code in there that you're actually using. All right, so that is the summary of interfaces. Hopefully that makes sense. There will be questions on this on the tests and on the quizzes. So if you have any questions, feel free to send me an email or show up in office hours.